Hi, students. Sorry for that little pause there. Give me just a minute. We're going to have a video here reviewing some things about inequalities, going over inequalities for Algebra 1. All right, guys, this is on page 5 of your packet. Again, you may or may not have your packet. You may be looking at a packet or may have been able to print a few pages from what I've posted on Google Classroom. This is designed to just be review of this, so I won't be going through nearly as many of the problems, but I just want to be sure, even though now this is part of pre-algebra, it's part of our agenda to review. So this is still part of our day 1. And so here we go. Please know that once we get into things that are truly new material, I'll probably go slower and do even more examples. So when we graph inequalities, and as you can see, there are some inequalities already on the screen. So things other than equal sign. So this is where we want to use an open circle. Or greater or less. When they do not have the line, the circle is going to be open. And we're going to use a closed circle. And I suppose someone could call it a dot instead of a circle. Closed dot, open dot. Or the ones with the or equal lines included. Because if it has the line, it means that number is actually included in the solution set. When it doesn't have the line underneath, it means it goes right up next to that number, but it can't actually be that number. So X is great. I'm going to look at these even problems for 2 and 4. So X is greater than 1, negative 1 rather. X is greater than negative 1, then I would go to negative 1, and I would be using, yes, an open circle, you got it, an open circle, and you might say, well, there is no negative 1. Well, you know, of course, it's just right here between negative 2 and 0. So I'm going to use an open circle there, and then we would want to shade, in this case, to the right, because to the right is where the numbers are greater than negative 1. My fancy arrows there. There's really just one of them is fine. I do usually put an arrow on the end, go all the way out to the end of the arrow because it continues in that direction, right? Not just through 8, but beyond. So like negative 0.5 would be okay. Negative 0.99999 with a decimal, right, would be okay, because that would be to the right of negative 1, but negative 1 is not included. On the problem below that, we have X is less than or equal to negative 5. So this time we're going to have a closed circle at negative 5. Oh, I'm still on my arrow, my bad. A closed circle at negative 5 with an arrow that goes to the left. Trying to erase the old arrow and it does not want to erase. It's very persistent. Please ignore this little guy right here. He does not, yeah. Everything is erasing except that arrow. There we go. All right, let me try this again. Negative 5. Here we go, negative 5. -5, close circle this time, and shading off to the left. There we go. Whew, labor of love. All right, so just a little brief reminder. I want you to at least have, I think you've all seen this before, but at least have some place where you had those notes written down. And depending on how things go in class, we may have IXL lesson today. I am kind of doing this in advance, so sometimes I have to just wait and see how class goes. So sorry that I can't say that for certain at the moment. And then this is just going the opposite direction. It can be kind of hard from the copy to tell if something is open or closed. Maybe not as hard for you as for me. So in this case, I believe that circle is open. So this is x is less than -2. Whereas this is x is greater than or equal to 4. X is less than or equal to 0. And x is greater than -3. And then a reminder that when you're solving inequalities, you must flip or reverse, use whichever one of those words if you like, the inequality sign when you multiply or divide by a negative number. If you've been in my class before, you probably remember my little song, right? You remember? You all know from, well, maybe you don't all know, but some of you know. The song, you might be familiar with the children's song, if you're happy and you know it, clap your hands, clap, clap. If you're happy and you know it, clap your hands. If you're happy and you know it, then your face will surely show it. If you're happy and you know it, clap your hands. All right, so if you multiply or divide by a negative, flip the sign. If you multiply or divide by a negative, flip the sign. I'll sing a silly song so you don't get it wrong. If you multiply or divide by a negative, flip the sign. So if in class I'm walking around and I look at your work and I say, do you really want to hear me sing again? Or I act like I'm getting ready to sing, chances are you forgot to flip a sign. All right. So we've got a rule for solving inequalities. That's a special rule. Otherwise, works very much like our typical equation solving. I'm going to do number 10 here because we didn't do any fraction equations yet, at least. So here on number 10, x plus 6 or x over 6 plus 2 is greater than -1. So we will subtract 2. So then x over 6 is greater than, that's a subtract 2, -3. Then we'll multiply by 6. And I get x is greater than -18. I did not need to flip the sign. It stays the same direction because what I did to both sides, what I multiplied by was the +6. The negative sign, the -3 was just already over there. That was nothing that I did to the equation. So don't get too flippin' happy and think that, oh, a negative sign, I have to flip it. Basically, if the coefficient of the x is negative, or if the x is being divided by a negative number, and then you would have to multiply by a negative, that's it's not just because your constant on the other side starts out negative. And then of course that would have been an open circle and shaded to the right. So a problem like number 11, we would need to reverse that sign to flip the sign, because in number 11, we are going to take away 8. And I was making sure I was actually recording. Oh, I'm sitting here on my couch talking to myself for no reason at all. All right, I know, TMI. So subtract 8 on both sides. Now I have negative 7x less than or equal to negative 7. So now I'm going to divide both sides by negative 7. Notice what I just said. I'm dividing by negative 7. So this becomes positive 1, just like it would with an equation, but that symbol is now going to go this way. Now, sometimes people are a little reluctant about changing the symbol. They're like, why would I do that? Well, let's just look at a quick example of why that has to happen. I'll just put this over on this side. Let's just take a couple numbers that we know. Like 3 is greater than negative 5. I think we can all agree 3 is greater than negative 5. 3 degrees is warmer than 5 below 0. But if we multiply both of those numbers times negative 2, so times negative 2 times negative 2, now I have negative 6 and positive 10. And if I want to compare those two, my symbol needs to open to the 10, right? Negative 6 is less than 10. So that shows us with actual numbers, and remember variables represent numbers, that when we multiply by a negative, because it kind of switches the number to the other side of the number line, it changes the relationship between the two. So same thing, right? And the same thing would happen with division. It does not happen with addition and subtraction. Okay, so, but with multiplication and division. All right, so if you were in class, I would have you do a few more of these just for some extra practice. But I'm trying to keep these videos relatively short. So let's look down at 15, because 15 has a fraction in it that sometimes throws people off. There are a couple ways that we can handle this. We could multiply everything in the equation by 4 at the beginning. And that's what I call clearing the fractions. So if I want, I can multiply everything by 4. If I do that, it's every single term. If I want to do that first, then even that 5 gets multiplied by 4. What that does, why I would even want to, is that would clear out that fraction and just make, it would just be 3x then. So 3x plus 20 is greater than 44. And then from there, I can carry on to solve. I can subtract 20. I've got 3x is greater than 24. Divide by 3. And by the way, at this point, you know, we're now in Algebra 1. If you can do this without, like, the things I just wrote in red, I would still consider it that you have shown me your work if I did not see the things in red. You may prefer to still show them because it helps you keep things straight, but you'll start noticing that sometimes I will stop writing those things. I will still tell you what I'm doing, but that can and probably should, as we get further in, that can and should become, and will for many of you, become a mental process. And again, if you have a method that you're showing your work, but in a little bit different way, you do not have to do it exactly like mine. Okay. So 15, I got rid of the fraction first. Some of my students love that idea because they just dislike fractions so much. But I could wait until the end to get rid of the fraction, and then I could use the reciprocal. That's not going to work out very nicely. Let's see here if I can get things going. Here we go, delete that and move this over, perhaps. Does not want to move for me, sorry. All right, there we go. Much better. All right, hopefully much better. All right, so in 16, thank you for your patience. So if I add 1 first, then I have -5 over 6x is greater than or equal to 15. Then I can use what's called the reciprocal. So remember way back in the day, when you divide by a fraction, you multiply by the reciprocal, which is like the flip-flop. So if I multiply by -6 over 5, which is like multiplying by -6 and dividing by 5 all in one step, the 6's cancel, the 5's cancel, and 2 negatives make a positive, leaving us just with x. We are multiplying by a negative, so the symbol is going to change direction. And then 15 times -6, -90 divided by 5 is -18. Or I could divide first. 15 divided by 5 is 3. 3 times -6, also -18. This would be a closed circle, wherever you want to put your circle. If there was not numbering, you could just choose a spot. Make sure you label it. And then shading is going this way to the left. That's where the smaller numbers live, to the left. All right, so that was just a brief review on inequalities, including that if you multiply or divide by negative, you will have to flip the sign. And then I did not give you a specific homework assignment on that. So in class, I will have just asked that students finish at least half of the problems. So it was numbered to 20, so that students do at least 10 of the problems, including the ones that I have done. So if I did 4, then you just have 6 more to do for practice. All right, thanks. Again, that was your review of inequalities.